Vanakkam. Now we are going to solve problem 3.24 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. The question is to find V naught using nodal analysis and MATLAB, but we are going to do manually. Okay, so this is the circuit given. First we mark the nodes and the current directions. Okay, so this is first node, this is second node, this is third node, and this is the fourth node with the potentials V1, V2, V3 and V4 respectively. And this is I1 current, this is I2, I3, I4, I5 and this is I6 current. Actually in our problem we are asked to find V0. So V0 is the voltage existing across this 8 ohm resistance. And this V0 can be written as the difference of this V1 and V4 potentials. Okay. So now let's get started. So when you use nodal analysis, we apply KCL, and here actually we have 4 nodes. So we are going to apply KCL for this node 1 and node 4 alone initially. Using that procedure, if we are able to find out this V0, it is well and good. Otherwise, we'll go for applying KCL to the remaining nodes V2 and V3. Okay. So first let's get started. So for this node 1, we apply KCL. So what are the incoming currents? 4 amps is the incoming current. What are the leaving currents here? This I1 and this I6 are leaving. Okay. So it is the summation of the leaving currents. So we need to apply Ohm's law for this. So it is 4, that is equal to I1 can be written as V1 minus 0 by this 1 ohm, right? So it is V1 by 1. Then what is this I6? I6 is V1 minus V4 divided by this 8. Take the common denominator here. So it is 8V1 plus V1 minus V4. So when you cross multiply this, we get this as 32, that is equal to 9V1 minus V4. So we can write this as 9V1 minus V4, that is equal to 32. This is our first equation. So now we are going for this node 4. So at node 4 we apply KCL. So there the incoming currents are this 2 amps in this I6 and the leaving current is I5. So summation of the incoming currents, this I6 plus this 2 amps, that is equal to leaving current I. So for this we are going to apply Ohm's law. So I6 can be written as V1 minus V4 when you apply Ohm's law divided by 8 plus this 2, that is equal to I5 is V4 minus 0 divided by 1. So it is V4. So if I take common denominator here, it is V1 minus V4 plus 16, that is equal to V4. So if you cross multiply this, we can write this as V1 minus V4 plus 16, that is equal to 8V4. So rearranging the terms, we get this as V1 minus V4 minus 8V. Rearranging the terms, we can write this as V1 minus V4 minus 8V4, that is equal to minus 16. That is V1 minus V4, it is V1 minus 9V4, that is equal to minus 16. This is our second equation. So now I like to bring the first equation here. Multiply the second equation by 9. So that we get this as 9V1 minus 81V4, that is equal to minus 144. This is the modified version of this second equation. Solve this two equation 1 and 2 dash. So for that I would like to change the sign here so that these two get cancelled, and here we get the answer as 80V4, that is equal to, so when you add these two, 32 plus 144, it is 176. So what is V4? V4 is 176 divided by 80. So that is equal to 2.2 volts. So we got V4. So substitute V4 value in this first equation, we get this as 9V1 minus 2.2 volts, that is equal to 32. So 9V1 is equal to 32 plus 2.2, that is equal to 34.2. 34.2. So V1 is equal to 34.2 divided by 9, that is equal to 3.8. So we got the second answer. So already we got this V4. So V1 is 3.8 volt and this V4 is 2.2 volt. So we know what is V0. V0 is equal to V1 minus V4. So it is equal to 3.8 minus 2.2, that is equal to 1.6. So this is the required answer. Okay. Thank you.